Hi children, welcome to today's class. Today we are going to see revision in chapter 3 for periodic assessment 2. What we are going to see in this class? Revision in chapter 3. What is chapter 3? Playing with numbers. What we have seen in this chapter about factors, multiples, prime, composite, then co-primes, HCF, LCM. Yes or no? What we have seen in this chapter, ma? Factors, multiples, prime numbers, composite numbers, co-prime numbers, some divisibility rules, and then HCF, LCM. That only we are going to revise at glance. See, what do you know about factor? Factor means what? What is factor? If we multiply any two numbers for getting an answer, we have taken the two numbers are called factors of the answer. What is that? When we take two numbers for multiple for getting the number, the two numbers are called factor of that number. That means that answer is called here product or multiple. We have taken two numbers for multiple, no? That are called factors of that answer. For example, already you know, anyhow we are recalling. For example, 6 means, in which are the tables that 6 will come? What are the tables that 6 will come? In 2 table and 3 table and 6th table. So 1 6 is 6, 2 3s are 6. So here factors of 6 means you can collect the numbers 1, 2, 3, 6. 2 3s are 6. 1 6 is 6. So we have taken 1 and 6, 2 and 3 for multiple to get the answer 6. That means 1, 6, 2, 3 are the factors of 6. What is that 6 called here? Multiple or product. Understood? This is about factors and multiple. Some properties of factors given. Factors means how should be. So a few points are mentioned. What regarding factors, what we have discussed? 1 is a factor of every number. What is that? Dash is a factor of every number. What do you write there? 1. 1 is a factor of every number, because in all the numbers category 1 will come. 1 into 6 6, 1 into 7, 1 into 10, 1 into 100, 1 into lakh, like that. So 1 is a factor of every number. Also every number is a factor of itself. Every number is a factor of itself. If you see their values of the factors, all are less than and are equal to that number. The values of the factors are always less than or equal to that number. For example, same 6. If you take, what are the factors of 6? 1, 2, 3, 6. What are their values comparing 6? 1 is less than 6 only. 2 is less than 6 only, like that. Yes or no? So that only we are telling the value of the factors are always less than or equal to that number. Are they finite? Yes. Factors of any number is always finite. Every number has limited factors only. Finite factors only. Understood? So about factors, what we have discussed, 1 is a factor of every number. Every number is a factor of itself. The values of factors are always less than or equal to that number. Factors of any numbers are finite. Every factor is an exact divisor of that number. If we can by the factor, we can divide the number exactly without remainder. So that only we are telling every factor is an exact divisor of that number. Understood? This and all regarding factors. What about multiple? Multiples we know well. Multiples nothing but the table of multiples of 2, multiples of 3, multiples of 8. This and all you know well. Clear? Think about multiples of 4. How comes multiples of 4? 2 2s are 4, 1 4 is 4. Yes or no? Here that 4 is coming in which table? fourth table and 2 table. That means that 1 4 is 4, 2 2s are 4. That 1, 2, 4 are factors of the number 4. The answer 4 is called here multiple or product. What is that? Multiple or product. So multiples of 4. Continue. What do you write? 1 4 is 4, 2 4s are 8, 3 4s are 12, etc. Goes on. So multiples of every numbers are infinite. What do you tell from this? Multiples of every numbers are always infinite. 100 4s are, 1000 4s are. It goes on. Comparing their value, what do you tell? Multiples of any number is greater than or equal to that number. For example, if you take fourth multiple, multiples of 4, what do you write? 4, 8, 12, 16, etc. Going. So infinite. Multiples are infinite. Value, see, 4 is equal to 4. But other than 4, all the numbers are more than that number. So from this, what do you tell? Multiples of every number is greater than or equal to that number. Clear? Infinite. And also every number is a multiple of itself. See, multiples of 4 only we have written, but in that 4 itself has a multiple. So what do you tell from this? Every number is a multiple of itself. Understood, children? So these points regarding multiple, you have to think about that. Clear? Multiples of any number. What we have discussed? Multiples of every number is infinite. All the multiples are greater than or equal to that number. Every number is a multiple of itself. Clear? So up to this we have discussed factors and multiples. Then prime numbers, composite numbers. What we are going to discuss about prime and composite, related factors based. See, if a number contains exactly 2 factors, what do you say that? That number is called prime number. What is that? What is the example? Sorry, what is the definition of prime? If a number has exactly 2 factors, that number is called prime. Suppose it contains more than 2 factors, it is called composite. See, only 2 factors, that means exactly means which are the numbers will come. See, for example, 2 means 1 2 is 2, that's all. 3 means 1 3 is 3. 5 means 1 5 is 5. Clear? This number has exactly 2 factors 1 comma 2. This 3 has exactly 2 factors 1 comma 3. This 5 also has exactly 2 factors 1 comma 5. Understood? So, if a number has exactly 2 factors called prime number, Prime, prime. The 2 factors also how should be? 1 and itself. See, 1 is a factor of every number, no? So that 1 is coming. And every number is a factor of itself. So that, say, 3 we have taken, 3 itself coming here. 5 we have taken, 5 itself coming one of the factor category. Clear? So, the prime numbers and the definition, what do you say? If a number has exactly 2 factors, that number is called prime. The 2 factors also how should be? 1 and itself. Clear? More than 2 factors means that comes to composite category. Clear? 4, 6, 8, 9, 10, these are the composite numbers. If you watch closely prime category, what are the numbers will come in prime category? 2, 3, 5, 7, 11, 13, 17, 19, etc. In this, if you see the first number 2, what is this 2? This is only even number. What are even numbers? Multiples of 2 fully even numbers. Which that means 0, 2, 4, 6, 8, 10, 12, 14, etc. These are the even numbers. Whichever left in middle, that are called odd numbers. Which are the numbers left there? 1, 3, 5, 7, etc. These are odd numbers. Clear? So that means here 2 is even number. Except this 2, all others if you watch, you come to know these are odd numbers. This only even number. Clear, children? If you watch prime category, prime numbers category, you come to know the first number only even number. What is that? 2. So from regarding this comes question, in which way? Dash is the smallest even prime number. What is the answer there? 2. 2 is the only smallest even prime number. Except that all other numbers are odd numbers only. Understood? Okay. After that, what we have seen? Composite. Composite means more than 2 factors. More than 2 factors are called composite numbers. In this prime itself, we have discussed about twin primes. What is that? Twin primes means that prime numbers whose difference is 2 are called twin primes. Then prime numbers whose difference is 2 is called twin primes. For example, 5, 3. 5 and 3 are prime numbers. Subtract them, 2 is coming. So the difference between the two prime numbers is 2. Therefore, that numbers 5, 3 are twin primes. What is that? Twin primes. 11, 13. 11 and 13 are prime numbers. The difference between both also 2. Therefore, both are called twin primes. So what do you observe from this? Twin primes means the prime numbers whose difference is 2 are called twin primes. Understood? Okay. Then what we have seen in this chapter? Up to this we have discussed factors, multiples, then prime numbers, composite numbers. Then divisibility of rules, test for divisibility of numbers. What we are going to revise now? Test for divisibility of numbers. Some rules we have seen. What are that? What is the use of these rules? In which way they are helping us? In which way they are helping us? For working, for division work, making calculation easier. These rules are helping us to solve the sum easily. Without normal division, we can check whether the particular number is divisible by this number or not. Understood? See, in this category, many rules are mentioned. Just we will see one by one. Divisibility by 2 rule. Rules, divisibility rules. See, first one, divisibility by 2 rule we will see. What it says? If a number has its ones place, in ones place has 0, 2, 4, 6 or 8, then that number is divisible by 2. If a number, for example 6312, in this number the ones place contains among these numbers any one, it can be divisible by 2. Clear, children? If a number has in its ones place 0, 2, 4, 6 or 8, then it is divisible by 2. Okay? Divisible by 3. What it says? Sum of the digits. Divisible by 3. Sum of the digits of a number. Sum of the digits of a number is multiples of 3. Then it is divisible by 3. Sum of the digits. What is that? See, 6312. If you take sum of the digits do here? What comes here? 6 plus 3 plus 1 plus 2. What comes? 6 plus 3, 9. 9 plus 1, 10. 10 plus 2, 12. Sum of the digits of the given number is multiples of 3. That means 12 is the third table number. Multiples of 3 only, no? 4 3s are 12. So, if the sum of the digits of a number is multiples of 3, then it is divisible by 3. Understood? Divisible by 4. What it says? For see, before going to apply this rule, we have to check two conditions. They are telling here two conditions. One thing, the number should contain 3 digits or more than that. 3 digits or more. If you take like this, 2 digits, 28 is a 2-digit number. Here we can't apply this rule. That means how do you check smaller digits and all? Means by normal division. When can you apply this rule? Means if the number contains 3 digits or more only, it is applicable. We can use at that time. Less than that 3 digits means we have to divide that number normally. This is the first condition. Clear? Next, what it says? The number must contain 3 digits or more. And then the last 2 digits of the number is either 0 0, the number is either 0 0 in its last 2 digits or multiples of 4. That means that number is divisible by 4. What is that, children? Again I am telling, here 2 conditions they mentioned. One thing, before applying this rule, the number must contain 3 digits or more. That means only it is applicable. Second condition, in its for example 6312, in its last 2 digits, the number is either multiples of 4 or 0 0, like that it should contain. That means that number is divisible by 4. See, first again I am telling, first condition, the number should contain 3 or more than that. 1 2 3 4, 4 digits this number contain. So here we can use the rule. Clear? On a second condition, we have to check its last one sentence place. Last 2 digits we have to check. That number should contain either 0 0 or multiples of 4. That means we can say this number is divisible by 4. Understood? What about divisibility by 5? What about divisibility by 5? The number must contain in its ones place either 0 or 5. Ones place should contain either 0 or 5. That means that number is divisible by 5. Why we are telling like this? See, just to check the multiples of 5. 1 5 is 5, 2 5s are 10, 3 5s are 15, 4 5s are 20, like that. In all the multiples, if you watch, what do you get? In its ones place 5 0 5 0 5 0. It comes like this only. So that only the rule framed like this. If the number contained in its ones place either 0 or 5, then it is divisible by 5. Understood? Divisible by 6, for this no specific rule is mentioned. If the number is divisible by both 2 and 3, then it is also divisible by 6. What is the condition for dividing any number by 6? If we have to apply the 2 conditions, divisible by 2 and divisible by 3. In both cases, the number is divisible, in the sense automatically it is divisible by 6 also. In that, no, in one case it is divisible, in another case it is not divisible, means you can decide the given number is not divisible by 6. Understood, children? What is divisibility by 6 rule? there is no specific rule for this. We have to apply divisible by 2 and 3 because 2 3s are 6. So we have to check these two rules. In both cases the number is divisible. We can finalize the given number also divisible by 6. Understood? Then divisible by 8. Divisible by 8. Like divisible by 4 only. Here what we have seen, two conditions they told. One thing, the number must contain 3 digits or more. Less than 3 digits means we can do their normal division work only. Like that only for 8 also. It is same as divisible by 4. Here two conditions they told. First condition, the number should have 4 digits and more. 4 digits or more than that the number should contain. And then we have to focus on the last 3 digits. This is the first condition. Then we have to focus on last 3 digits. That means ones, tens, 100. Last 3 digits of the number contain either 0, 0, 0. Either 0, 0, 0 or multiples of 8. The number should contain. That means we can say the number is divisible by 8. Understood? The number, first condition, the number must contain 4 digits or more. Second condition, the last 3 digits. Last 3 digits nothing but ones, tens, hundreds. Okay? The last 3 digits of a number contains either 0, 0, 0 or multiples of 8. Clear? Next, divisibility by 9. What it says? This is same as divisible by 3 only. In 3 what we have seen? If the sum of the digits of a number is divisible by 3, then it is divisible. Like that only divisible by 9 also. Divisible by 9. If the sum of the digits is divisible by 9, then it is divisible by 9. Okay, same as third rule. What about divisible by 10? Very easy. If you watch the multiples of 10, what comes? 1 10 is 10, 2 10s are 20, 3 10s are 30, 4 10s are 40, etc. If you closely watch its ones place, what do you know? All are zeros only coming. Yes? Yes only. So from this the rule came here. If a number contain, if ones place has 0 only in its ones place, then we can say that number is divisible by 10. Other than that, other than 0, some other number present. 637. Here 7 is in ones place. What do you say? This number is not divisible by 10. Understood? So what we need there in its ones place? Only the number 0. Understood? What about divisible by 11? This is little bit bigger only but easiest. Okay, divisible by 11. What it says? If the difference between the sum of the digits at odd places, sum of the digits at odd places and sum of the digits at even places, sum of the digits at even places is either 0 or multiples of 11, means that number is divisible by 11. What I am telling? If the difference between sum of the digits at odd places and sum of the digits at even places is either 0 or multiples of 11, that means that number is divisible by 11. See, we will see one sum. See 406, 839. Say whether this number is divisible by 11 or not. What to do? Will you do normally? No need. Without normal division, we have to check whether this number is divisible by 11 or not. For that only we are using these rules. What it says? First of all, we have to split the numbers according to the odd and the even places wise. See, this is the first place, so odd. This is a second place number, so even. This is the third, odd. This is the fourth place, 4, even. This is fifth place, odd. This is sixth place, even. So according to the odd and the even, we have split it. Now collect all the even numbers one line, odd numbers one line. Even numbers means what are that? 4 plus 6 plus 3. 4 plus 6 plus 3. 4 plus 6 what comes? 10. 10 plus 3, 13. Sum of the digits at even places we have taken. Clear? 4 plus 6, 10. 10 plus 3, 13. Likewise, odd places numbers, this, this. Yes or no? So here 0. Here 8, here 9. So 8 plus 9, 17. 17 plus 0, 17 only. See what I did here? Given number is divisible by 11 or not. I have to check. For that what I did? I have splitted the numbers according to their odd and even places wise. And then sum of the digits in both cases I have found. Clear? That difference I am going to do. Difference between both. So 17 minus 13 is equal to 4. This 4, actually rule of 11, what it says? The difference is either 0 or multiples of 11. Multiples of 11 means what are that? 11, 22, 33, etc. But here what we got here? 4 only. 4 is not multiples of 11, not equal to 0 also. Therefore, we can decide the given number 406,839 is not divisible by 11. Clear children? This is a procedure for applying the divisibility by 11. To check whether the number is divisible by 11 or not, what we have to do? First of all, we have to split the numbers according to the odd and even places and find the sum. Take difference between both. Check the answer is coming either 0 or multiples of 11. In this category, if you get answer, you can write here the given number is divisible by 11. But I got here other than these two category only. 4 I got. So 4 is not multiples of 11 and not equal to 0 also. So that I wrote like this finally. Understood? That's all children. Divisibility by 2, 3, 4, 5, 6, 8, 9, 10, 11. Rules discussed up to this. After that, what we have seen in chapter 3, some more divisibility regarding this. Some more divisibility rules also we have seen. What is it? If a number is divisible by another number, then it is divisible by each of the factors of that number. What it says? If the number is divisible by another number, then it is divisible by each of the factors of that number. What is this meaning? If a number is divisible by another number means, then the first number is also divisible by each of every factor of the second number. Okay, this and all we have seen in some more divisibility rules. Just go through in the book. Okay, next thing, what we have seen here, common factors and common multiples. Common factors and common multiples. Common factors means nothing is here. First of all, you have to find the factors of the given numbers then pick up which are coming in both category, that are called common factors of the given numbers. Common multiples also same as like that only, but here you have to take multiples of the two numbers. While finding common factors, there is a method given in the book. What is it? Prime factorization. What is prime factorization, pa? The process of finding any prime factors of the number is called prime factorization. What is it? The process of, the method of, the work of finding prime factors of any number is called prime factorization. See, for example, 18. I have taken the number 18. Write all the factors of 18. What do you write? 118 is 18. 2 9s are 18. 3 6 are 18. These are the factors of 18. But here all the factors, this is in general I wrote all the factors of 18. What are the factors coming here? 2 prime number, 3 prime number, 6 composite, 9 8 also composite. What about this 1? 1 is neither prime nor composite. What is 1? 1 is neither prime nor composite. Okay. Prime factors of 18 means only prime factors will involve. How to find it? Factor tree method is there. See, factor tree wise I am trying. Split this. 9 2s are 18. Here 2 is the prime number. Leave it. What about this 9? 9 is the composite number. So we have to split again. In which way? Factor wise. 3 3s are 9. 3 is the prime. So that's all. Sum is over. So prime factors of 18 means, what do you write? Prime factors only you have to write. 3 into 3 into 2. 3 3s are 9. 9 2s are 18. This method is called a factor tree. Like tree, it is coming. So this is called a factor tree method. Find the prime factors of the given number using factor tree method. Means you have to choose like this only. Get the answer only prime. Okay. The process of finding prime factors of any number is called prime factorization. Clear, children? But that means you can ask, ma'am, that means this and all wrong. No. In general, this and all coming. Here prime factors, composite factors, one is compulsory factor for every number. So all the one mingled there. But this is only prime factors category we solved. 18. Okay. Common factors based on familiar definition we have discussed. What are that? What is that? Co-primes. Co-primes means the numbers which have exactly common factor as 1. They are called co-primes. What is that co-prime mean? Co-prime means the numbers which have common factor as 1 only are called co-primes. For example, 2 and 4, 4 and 5. Take 4 and 5 are natural numbers and also consecutive naturals. So they contain common factors. What they contain? We will see now. First write the factors of 4. Factors of 4. What comes? 1, 2, 4. 1 4 is 4. 2 2s are 4. Factors of 5 means 1, 5. 1 5 is 5. That's all. Common factors. 1 only. That means these two numbers are called co-primes. What is that? Co-prime numbers. If the numbers have common factor as 1, they are called co-primes. Clear? So 4 and 5, if you see what they are, consecutive natural numbers. Consecutive, nothing but next immediate. So consecutive natural numbers are always co-primes only. Co-primes condition, they must have common factor 1. Clear? Okay, up to this we have discussed factors, multiples, prime numbers, composite numbers, then even numbers, odd numbers, divisibility rules, and then common factors, common multiples. Co-primes also we have discussed. Prime factorization we have discussed. The finally two main topics are there. What are they? HCF and LCM. What are they? HCF and LCM. What is HCF? Highest common factor. What is HCF? Highest common factor. What is the other name of HCF? Greatest common divisor. In division wise, how do you say? Greatest common divisor. GCD. GCD stands for greatest common divisor. Okay, that we will see now. For example, 18, 48. Find the HCF of given two numbers. What to do? HCF of two numbers or two or more numbers is the product of the highest common factors. Product of the common factors we can tell. One, see, in these two ways we can try. One is prime factorization method. Another one is in general. In general, if you find HCF of any two numbers, what you have to do means, you have to find factors of two numbers and then common factors. Then pick up in the common factor which is the highest. That is the required answer. But if you try prime factorization method for finding HCF, what to do? Common factors finding time, you have to multiply them. That is the HCF, required HCF. Clear? I am putting in two ways also. First one thing, general method I am trying. Writing all the factors. Okay, 18 means what comes? 1 18 is 18, 2 9s are 18, 3 6 are 18. All the factors of 18 I wrote. 48 means 148 is 48, 2 24s are 48, 3 16s are 48, 4 12s are 48. That's all. 148 is 48, 2 24s are 48, 3 16s are 48, 4 12s are 48. Then 6 8s are 48. 6 8s are 48. All the factors are 48 I wrote. Common factors. These are all factors. Now common factors I am going to pick up. 1, 2, 3, 6 here, 6. Clear? 1, 2, 3, 6 are the common factors. HCF means what do you say? Highest common factor. No. So in this category, which is the highest, that is the final answer. This is one type. Here all the factors involved. I am doing the same sum in prime factors method, prime factorization method. I am finding HCF of the given two numbers. See, 18 means how comes? By prime number if you divide, what comes? 9 2s are 18. This is a composite, so we have to divide again. By 3 also prime. 3 3s are 9. Okay. Take 48. 1 3 is 3. Remainder 1. 16 comes. 18 comes. 6 3s are 18. So 16 3s are 48. Composite number. So we have to divide again. 2 table. 8 2s are 16. Again 8 is the composite number, so we have to divide. 4 2s are 8. 4 also composite number, so divide again. 2 2s are 4. 2 is the prime number, stop the sum. So 18 factors, especially prime factors means what did you do here? 2 into 3 into 2. 2 3 3 are the prime factors of 18. 2 3s are 6, 6 3s are 18. Coming correctly. 48 means this fully. 2 into 2 into 2 into 1 2 3 4 no into 3. 2 into 2 into 2 into 2 into 3. 2 2s are 4. 4 2s are 8. 8 2s are 16. 16 3s are 48. Now common factors. 2 and 3 only. Okay. Prime factorization wise, if you find HCF, what I said, you have to multiply their common factors. Product of the common factors is its HCF. Clear? In general, highest common. In common factor category, highest number you have to pick up. But in the prime factorization, you have to multiply the common factors. So 2 3s are 6. 6 is the HCF. Understood, children? What I did it, for finding HCF of any two numbers, what you have to do, in two ways I have shown. One thing, using all the factors. At the time how to find HCF means, in the common factor category which is coming highly, that is our final answer. In the prime factorization category, how to select the common HCF means the product of the common factors is our final answer. Understood? Next, last topic, LCM. What is LCM? Least common multiple. What is that? LCM stands for least common multiple. See, two numbers I am taking here, 10, 5. Find the LCM of this. LCM of two numbers 10, 5. Find it. What to do? This also in two ways we can find. LCM means least common multiple. First of all, you have to write the multiples of the given numbers, pick up the common multiples and then select which is coming least level. That is required answer. That is one method. Second thing, while using prime factorization, at that time how to find LCM means, LCM is the product of common factors and non-common factors. What is that, children? Common factors and non-common factors product. We will put in two ways also. Just watch. See, in general, I am going to find the LCM of the given numbers. For that, first what I do? Multiples of 5. I am going to write 1 5 is 5, 2 5s are 10, 3 5s are 15, 4 5s are 20, 5 5s are 25, etc. Multiples of every numbers are infinite, no? So, etc. It goes on. Then multiples of 10. Multiples of 10. 1 10 is 10, 2 10s are 20, 3 10s are 30, 4 10s are 40, etc. Common multiples of 5, 10. Common multiples means 10 only coming correctly in both. So 10, 20, definitely what comes? 25 after 30 only, no? So 30, 10, 20, 30, etc. goes on. So LCM, least common multiple. In common multiple category, we have picked up in both category as 10, 20, 30 are the common multiples. In that, which is the least level? 10. That means 10 is the LCM of the given two numbers 5, 10. Clear, children? This is in general, writing all the multiples. all the multiples means taking few multiples. We found how to take LCM. Prime factors wise I am trying. Prime category. What comes here? Prime factors of 5 means 1 into 5 only. What about 10? 2 5s are 10. That's all. So 10 means here 5 into 2. That's all. Prime numbers means 5 only comes here. For 10, 5 into 2 only comes. Just a common multiple. 5 only. Common multiple for 5 and 10 is 5 only. What about non-common? Here factors, sorry, common factors. What is it? Common factors, because we have divided, no, here, not multiple. So in division, these are called divisors, nothing but factors. Okay, so common factors of 5 and 10 is 5 only. That means what is called non-common factor? Whichever coming without pair is called a non-common factor. In that category, if you say in both line 2 is the remainder, that means without pair, it is called a non-common factor. So common factor is 5 here, non-common factor is 2 here. LCM, what I said just now, common factor into non-common factor. That means common factor is 5 into non-common factor is 2. So product, LCM is the product of common factor and non-common factors. So 10 is the answer. Anyhow, our answers are coming correctly. This is generally by taking few multiples of both numbers, how to find the LCM. This is using prime factorization. How to find the LCM. In this category, you must watch this. LCM is the product of common factor and non-common factor. Understood, pa? Regarding this LCM, one important question is there. Important model is there. Find 3 digits smallest number which is exactly divisible by this. Find the biggest 3 digit number which is exactly divisible by the given numbers. Like that may comes. So at the time what to do? Exactly divisible by the given numbers means you must choose LCM of the numbers only. See, if you watch the exercise 3.7, 4th question, 5th question and 9th question, what is given here? Determine the smallest 3 digit number which is exactly divisible by 6, 8 and 12. Determine the smallest 3 digit number which is exactly divisible by 6, 8, 12. Exactly divisible means we have to find its LCM only. See, in that model, let me work out one sum here. What is the question, pa? Determine the smallest 3 digit number. Smallest 3 digit means don't consider the general 10, 100, 1000. 1000 is the smallest, 100 is the smallest 3 digit number. 1000 is the smallest 4 digit number. 9, 99, 999, these are the biggest 1 digit, 2 digit categories. Clear? But in this exercise, they are not talking about that. Determine the smallest 3 digit number which is exactly divisible by 6, 8 and 12. You have to select one number. It should contain 3 digits and the smallest level. That number must be divisible by the given number 6, 8 and 12. So what is that number? This is the question. So what to do? In 3 categories also that number should be divisible means you have to find here LCM of that 3 numbers only first. So smallest 3 digit number you have to pick up. It should divisible by 6, 8 and 12. Exactly. Means what is that number? This is the question. So in 3 categories also it should be divisible. For that we have to take LCM of that number. Take separately, individually you find. 6 means 3 2s are 6. 8 means 2 4s are 8, 2 2s are 4. 12 means 2 6 are 12, 2 3s are 6. Prime factors of 6, what comes? 3 into 2. Prime factors of 8, 2 into 2 into 2. Prime factors of 12, 2 into 2 into 3. All the prime factors written. Common factors. Pick up common factors. Clear? In 3 categories coming time, first of all you have to select which number is coming commonly in 3 cases. That is the common factor. Okay. That's all, our work is over? No. And then check in another 2 categories which number is coming commonly. 2. Here 3. So first you have to watch 3 lines also. In that case we got one number, that is common factor. After that you have to check in another 2 categories any number is matching or not. Yeah, in 8 and 12 2 is coming, so this also common factor. In 6 and 12 3 is coming commonly, so consider that also common factor. Now non-common factors. Non-common factors means, what do you think? Here only the 2 is balanced. This is non-common factor. Just now I told LCM means product of common factor and non-common factor. Yes or no? So common factor into non-common factor. Common factor category, what's coming? 2 into 2 into 3. Non-common category, 2 only is coming. What is the answer? 2 2s are 4, 4 3s are 12, 12 2s are 24. So 24 is the LCM of this. 24 is the LCM of these 3 numbers. That means that number only exactly divisible by 6, 8 and 12. Correct? Correct only. Okay, but what is our question? You have to find the smallest 3-digit number which is exactly divisible by this. But we got now 2-digit number only. So what to do? We need to get smallest 3-digit number which is exactly divisible by the given numbers. For that, what we have to do means the multiples of LCM we have to write. What we have to do here? Multiples of the number 24. Multiples of 24, what comes? 124 is 24, 2 24s are 48, 3 24s are 72, 4 24s are 96, like that. Yes or no? Correct or not? Check. Okay. Then 5 24s are 210. 120, yeah. What comes? Just check. 4 5s are 20, remainder 2. 2 5s are 10. 10 plus 2, 112. 20. 120. 4 5s are 20, remainder 2. 2 5s are 10. 10 plus 2, 12. So 120. 6 24s are 4 6 are 24, remainder 2. 2 6 are 12 plus 2 14. 144 comes and goes on. We no need that much level. We need a smallest 3-digit number which is exactly divisible by the given numbers. In that 120 we got. This is the smallest 3-digit number which is exactly divisible by the given number. Yes or no? Up to this 2 digits only we got. Clear? This is the first smallest 3-digit number. First number containing 3 digits which is divisible by this. So that is our required answer here. A number, the smallest 3-digit number which is exactly divisible by this means what is the answer? 120 is the final answer containing 3 digits. Also divisible by the given numbers. Understood, children? So what I did for this question? We have to select smallest 3-digit which is exactly divisible by that given numbers. Exactly divisible in the sense we have to find its LCM. LCM means prime factorization wise if you find it, in which way you have to do? product of common factor and non-common factor. At that time your answer is 24. 24 contains 2 digit only, but we need 3 digit smallest. So what we have done, the product, the multiple of that number we have to write. In that smallest 3 digit only we need. So where we are getting the first 3 digit, that is our required answer. Understood? Okay ma, almost many topics whatever given in the chapter I have revised. You also revise yourself. Thank you.